Hello, everyone. Welcome to the show. Happy Thursday. As you can see, co-host and extraordinary friend Nikki Pike can't make the show today, so we're flying without him. But I'm just going to go ahead and bring on our special guest for today. Bring Fynes back onto the show. Hey, how you doing?
Hey, Nick.
Hey, I think you're definitely earning your keep as one of the top three friends of the pod.
Yeah.
As you know, Cote, I was catching up on the podcast format of this show yesterday, and when Cote came on last, we had a debate of who may be the most popular guest or not. But
It's going to be like that Saturday Night Live where you leave a jacket with the number on the back with the house coat.
All right, we're gonna have to talk to Nikki and we'll get some jackets made. But shout out to our friend, more friends of the pod, David Zinzi and Keith Lee in chat. So yeah, we're just getting back from Cloud Foundry Day in Palo Alto. So if you haven't seen our live show, that's all posted and ready to go. We had in just in time delivery, we had some last minute changes to the roster, but we got a pretty good panel on the show on last week. I think it was a Wednesday. Yeah, I think Wednesday seems about right. But yeah, we had Behan from SAP, we had Greg Otto from Comcast, we had Amelia Downs, and David Stevenson from the Broadcom engineering side. So great show. Check it out if you haven't seen it so far. But today, we're going to be exploring some of the work that our friend Mark's been doing with, I guess, maybe some real world customer examples about requests and things coming in, and how we can use Tanzu platform to make kind of like a regional data services type of deployment. And that's kind of the theme for today's show. And I guess before we get into that, do you have any fun banter or anything? What's going on in your neck of the woods? Any weather reports or anything fun you've been working on the side, so to speak?
Well, I was explaining how CF worked just this week to an IT leader, and it was actually really interesting. The reaction I got in the middle of the presentation was, hang on a minute, you're telling us about how you can do all these things and you're almost making them trivial, and they're super challenging for us, and you're making them out like they're nothing. And I'm like, yeah. And he goes, if that were true, why isn't everybody using Cloud Foundry? And it got into a whole, I had to go off script and start talking about CNCF and CFF and the Cote explanation on one of the CF weeklies I caught months ago, where he talked about how the world went into this, became enamored with a universal south-facing interface that Kubernetes presents and kind of forgot about the need for an app platform. And it was funny to kind of go off script and just try and think a little bit about it. But the thing that got this guy's attention was a little service called CredHub. As a specific, it was in the greater context of service bindings. And that's something that, every time I present and we talk about this stuff, I'm always interested in the feedback loop and what latches on, or what is it that people get, like, kind of go, that piece. Yeah, and it's always interesting because the piece that keeps coming back, and this is probably the third time this quarter that I've heard it, is the challenge of getting your secrets into your apps, and how we didn't even think about it for the last 10 years. We had services in the platform where you would just bind to them. You weren't, and then the interesting part was the dev foundation would have a dev Postgres or MySQL. The UAT one would have a different one. Prod and Beer would have different ones, but your DevOps pipeline would just say bind to the database called foo, and it wouldn't matter. Environment. So out of our 12 factors, that's my new favorite of the 12 factors.
Yeah, very nice. And I guess it kind of brings into this. We're kind of discussing a little bit in our green room discussions, as our guests have become more and more akin to. And a couple of weeks back, we had Deshaun and Keith on the show, and the green room was wild. And I wish we had recorded it, because we would have made like the best short ever, and probably a very, very popular just sub episode in itself. But the concept of like how ahead of its time Cloud Foundry was, and some of these concepts are, and still almost how still very relevant, how even more, it's still somehow ahead of its time, a decade plus. Some of these concepts that we've just been living in, the rest of the world hasn't seen, so to speak, is always always intriguing how it continues to resonate. So
yeah, and I'll tell you, I've been really noodling on that very topic lately, and I think it's not about what's automated, but it's about the layers of abstraction within the automations. And we'll see it. We actually see it today because it's what I kind of got out of what I've been working on lately. It was like, aha, the kind of the epiphany moment, which we'll see a little bit later.
Very cool.
Yeah.
Well, yeah, I'm super excited to see what's going on. I know you've been kind of pushing the boundary here lately on some things, and it's more of just kind of I would say maybe refreshing or just kind of exploring what's been around for a while.
Yep.
So yeah, let's. What do you want to dive into first? How do we set the stage?
So I was thinking a little bit about this. You know, one of the key messages that we've had forever with Cloud Foundry is it just works. Well, what does that actually mean? It means it's highly available. And, you know, we were all indoctrinated, but in a way that was based in fact that, you know, if an AI or container image within Diego failed, it would be redeployed. And if the VM, the worker equivalent, the Diego cell wasn't there, another one would get used. And if the cluster was gone, it would use the other two zones. And the availability was always there. And it had what we call the 4 or the 5 layers of HA. And I've had customers show me like I think we used to call it our validated design, where you have your 3 racks of servers. And if you wanted to be super available, you would leave 33% headroom in them, and you can afford to lose an entire rack and not skip a beat, because at the speed at which containers get relaunched, you would get back to full capacity in the remaining 2 racks plus the zones, AZs.
Right.
And so that's awesome. And then you'd say, well, what about mission critical tier 1++, where I have to be tolerant of an entire data center going down? And so this is where you'll see a global load balancer, maybe a vanity URL, and it'll layer 7, and it'll have the whole thing somewhere else. And so I'm working with a customer that does this, and it's bulletproof, works like a charm. But that brought up a topic around, that's great for the app layer. Now let's talk about the underlying services that those apps need. Whether it be caching, or that's so much, because that's not so much a system of record. A data fabric would be, but a messaging and database are tricky, because now where do they live, and how do they contend with the failure of an entire data center?
Right.
And you know, we've had services in the platform, we've had them, thanks to the power of bosh underneath, be able to spread across our zones, much like the way it would run PCF itself. But it brought up a question around, how can I make my backing service, for example, RabbitMQ, tolerant of that first data center failing, so that the apps in the second data center, when the global...
I think we lost Mark here. Give us 1 minute to regroup. Yeah, he's not. Yeah, and that's TFC mentioned.
No, we're back.
All right, you're back.
Don't adjust your TV set.
All right. Yeah. Did you fail over to your other data center?
I think
we lost you. We lost you for about I don't know.
I'm back.
All right.
I don't even know where. Oh yeah. So the I don't know when I lost the signal.
Lost the data center, right?
Yeah. So what are you gonna do? Where's your other messaging backbone, for example? And if I connect to that one, have I lost messages that are stuck in a queue in a data center that might be offline? And so this is background. And then I started thinking about how PCF works and how we traditionally just connect into, like in the data center, we would connect to a vCenter and spread our workloads across the infrastructure it owns. And I thought about this little unknown feature called multi-CPI that's been hiding there inside the bowels of CF for years. And it essentially lets you onboard multiple vCenters. And I thought, well, what about if I make a small footprint foundation, I put Rabbit in it, and I configure the zones to actually use different vCenters which means if they're routable east-west, I could actually have zone 2 of a rabbit cluster live in a different building. And so we brought in the rabbit team, and they all signed off. As long as you have less than 5 milliseconds latency, Rabbit itself will support the long-range connectivity. And this is kind of a little bit like the way some of the hyperscalers work, in that their AZs are different physical buildings. And so I thought, let's see if this actually can work. So I know you're the king of home labs, but I somehow scrounged enough boxes in my basement to actually run VCSA, vCenter appliances individually and independently. So I have a true share nothing, except for a couple of pfSense boxes to give me a routable network between different subnets. So let's see if I can I bring online my desktop without losing connectivity. It's easiest to share. Let me see. I'm going to share a screen. You guys can tell me if I get a screen to share here. Am I getting the Excalibur?
We see. Yes. Yeah, I think so. Yeah.
Awesome. All right. So what I said was, again, I have a data center, and I want to. It's all great when you have 2 data centers and you have your GSLB in front.
Yeah, we may want to zoom in a bit.
Yeah, yeah, no problem.
Yeah, I'm trying to get us. There we go. Yeah.
Okay, and we know this pattern. We've done it before. In fact, the really nice thing is if you do layer 7 checking from your balancer, it'll check that the individual apps are alive, not just the LTMs. This is a nice pattern. Works great. But the question was, could I create some sort of super highly available and always consistent backing service? Or if it's a database like an RDBMS, can I have the shortest possible time to resolution if I have to trigger a failover of a database? With the messaging, it was very interesting because Rabbit supports the technology known as quorum queues, which are super efficient, and it understands the anti-affinity rules between the different brokers.
Right.
So what I put together was this picture, and I'm going to try and get this to fit. So can you guys see this picture here?
Yeah.
So what I've got going on is I've got a vCenter, a resource pool, I've got a subnet, and I've got another vCenter which can live anywhere that's routable. We were talking about the layers, layer 3. It's not the same subnet.
Right.
And the third one, and you want the rule of 3. You want an odd number rule, because what we're looking for here isn't always available, even in the event of the loss of an entire zone. And so I have behind the scenes of that vCenter 1, Center 2, Center 3. There was a lot of fun building this lab out.
Yeah.
Now, I was asked by someone, don't make me stretch layer 2 network. I don't want to be playing in the same subnet. Nope. The Rabbit technology, the Postgres, none of the services need the same subnet.
Well, that's really good, because I think a lot of people, a lot of these large enterprises may have a metro deployment, but then you start stretching layer 2 across those. That's when it gets really
scary
and just like, let's not do that.
Even within one data center, if I'm doing my 3 racks, my preference is to have the racks have top of rack switching with subnets that are defined for each. It's not essential, but it's cleaner and makes the networking easier. So I have this picture. I don't want to have to stretch the domain, the workload domain in the VCF parlance across the data centers. I want as close to share nothing as possible. I'm not stretching any storage arrays. Each data center has its own disks that are local. All replication will be the responsibility of the service itself. I don't need the disks to do it. And the question was, how hard would it be to set this up? And this is where, again, we were talking about how Bosch is ahead of its time in so many ways. Underneath the covers, you guys could have seen the real example on the left of 3 different clusters. And I've got a 192.168, I've got a 10.0, 10.1, or maybe I can't remember. I've got 3 subnets that are 10.0, 10.1, 10.2.
Right.
Then what I want to do is I want to define 3 bosh availability zones. Zone A will point to cluster 1, zone B will point to cluster 2, zone C will point to cluster 3. But those clusters have to be accessed through different vCenter entry points. But that's it's an implementation detail. Then what we'll also do is we'll tell it when we're defining the subnets, hey, if it's subnet 1, you have to live in zone A. If it's subnet 2, you live in zone B. Subnet 3, you live in zone C. And we're building up the layers. We just do this once. So these bosh zones will have a subnet that understands the routing topology. So the 10.0 network is in my first data center, the 10.1 is in my second, the 10.2 is in a colo or a third data center. All tightly coupled in the sense that they're close, not tightly coupled. But you meet the throughput and the latency requirements of your network, because there's no automation that can fix a bad interconnection between your zones. You always want your zones to have really high bandwidth, really low latency, because they're always available.
Yeah, so you have 3 separate data centers here, essentially.
That's the plan, yes.
With good pipes in between them, but you have they do not depend on each other.
Correct.
Right?
Exactly.
Yes. I like where we're going here. Right.
All right.
So let's
then,
continue.
Yeah. So we're still configuring bosh. We haven't talked about Rabbit or Postgres or any other services. We're just doing the bosh layers. Now I'm going to define one bosh network from my stretched services. And it turns out, we talk about multi-CPI, which we'll see in a minute, but when you define a bosh network, you can define multiple subnets to be part of that same one single bosh network. So what we do is we add our subnets to the stretched services bosh network.
Yes.
And then on the right side, we create bosh availability zones, like I said, zone A, B, and C. And so we'll have our AZs that we can pick which we want to use. And we have our services network that understands if I'm in zone A, what subnets within that network I'm allowed to use. And then we start deploying tiles into the ops manager of the CF to leverage these settings. So let's jump in and take a look at what it looks like.
Sure.
And okay, so we'll go into a tile. You guys can see that? Let's make that.
Let's make it zoom in as much as you can. There we go.
How's that? Okay.
Perfect.
So the default one is just everyone's used to seeing a default vCenter config or a default config for your cloud provider. You literally add vCenter config and you define another one. You give it a name, you say where your vCenter lives, your credentials for it. You tell it what disks for ephemeral and persistent storage that this vCenter has access to and the storage type or the data store clusters that it has. So again, we're being very specific about the data store configuration, the storage config for this CPI, for this target, if you're doing NSX or regular networking. And that's it, right? So we can add vCenter configurations and with no overlap between them. One interesting side note, I did a little hack years ago at multi-CPI in one data center, in one deployment, where we wanted to give the really good disks, like the higher performance vSAN configuration or the other, or I can't remember, maybe there were SSDs at the time when there weren't many, as a target for the disk-intensive bosh jobs, like databases. And so you could have, because remember, we comma delimit our data store configurations in bosh and then let the platform do its thing and 10,000 containerized apps work and services and so on. And we don't ask about the disks anymore other than are they full yet. And sure, you can use data store clusters and you can do things to make it performant underneath, but we kind of have one giant consumer of a set of disks, a set of data stores top down.
Right.
What if I wanted to have, say, Postgres use NVMe drives and the regular foundation will be okay with SSD drives? You can define another vCenter configuration that points to the same everything as the first one, but you change your disks.
I hadn't thought about that because I was like, oh, well, like, So with the Gen AI tile work, I've done some things similarly with zones where let's bring in a zone of GPUs.
Mm-hmm.
But that's still using the same vCenter config. I didn't think about at that level
Yep.
where to change the persistent and ephemeral storage.
Yeah.
I learned something from you every time I talk to you.
That's just a bit of hackery here.
Yeah, well, it's a great idea. Anyway, yeah.
It gives you that. Like you can. I like to tell customers that when we look inside a vCenter and we have a cluster, you create a resource pool and point to an AZ in a resource pool, because the compute demands of a data service are very different from the compute demands of a Spring Boot microservice or .NET microservice that spends most of its time, frankly, waiting on the service. You know, the request from the user, we go wait for the database backend system, will ever come back, and we get lots of scalability, but it's a very different compute profile. Now, that's all well and good when you 50% headroom for your compute, but when you start to get close to that compute ceiling and there's a big fight and there's a lot of screaming and a lot of contention at the hypervisor to schedule things, you might want, and I haven't explored it in depth, but I do think about make a resource pool for the CPU sensitive things. If you can't give it a dedicated cluster or host group within a cluster, make a resource pool for it. So and again, these are things where the resource pool can just be a label, but it's a label that if you get into trouble, you can configure it to give it a little bit of a bump or a reserve on the compute cycles if they get stressed. So again, lots of fun things you can do here, because once you define your zone, we're doing vCenter configs. We're going to get to zones, but whether it be the storage that the CPI gives you, or the host group or resource pool that the zone is going to use, these are levers that are at our disposal to really streamline what the hardware is actually doing for us. So we've made our zones A, B, C. We made our vCenter configurations. I overloaded my naming. Sorry, guys.
No problem.
I make availability zones next. So zone A is going to use the IaaS configuration for zone A, the first vCenter. And, we're all joking when you recommended a certain box for me. I went, man, that thing is a beast. So I have beast cluster.
Beast cluster. All right. Yeah.
What is it? The HP Z8 G4?
Yeah.
Love that machine. It's a cluster of one, but it's got a good beefy 2020 something chip in there. Relative to all the others. Zone B is using an old Dell box that a Super Micro box. This is the little Nook thing. It's the little horse that should be in a Budweiser commercial. It's along with like 6 small Xeon D cores, and then the C is another older box. I've got like a Dell 7 something box.
Oh, so you scaled. So you scaled across all. Well, that's another thing too.
There's nothing normalized here. This is functional only.
Yeah.
Where I found it very interesting was I went in to configure a tile, and the tile says, "What network do you want to use?" And I went, "Well, I'll have 3 of them." And that's when I discovered, or reminded myself, that when I go to define a BOSH network, you've got this. It's not just for a subnet. You can have as many subnets as you want in one BOSH network, much like you can have multiple clusters in an AZ. And so I said, okay, I had the regular the VM network, my original, but 10.2. But look at this, zone A. And then I would do another one, different CPI will be used for this, but this is zone B, and this is 10.0, and then 10.1, and that's zone C. So if you go back to the sketch, what we've seen in the Opsman, which I think is amazing because we'd be drowning in YAML right now, is that we have our zone A, zone B, and zone C using a 10.0, a 10.1, and a 10.2, and a 10.0 set of subnets. And the subnets are only allowed to live in a particular zone, or the zones are only allowed to pick IPs from a particular subnet, whichever way you want to spin that. But we've tucked it away under the covers. We have a services network now, and we've got the AZs that stretch different vCenters. And that was the game plan. So then it was a question, will this work?
Yeah.
Well, all right, BOSH is configured. It's got stretched services, and it's got zone A, zone B, zone C. Let's go to the Rabbit tile.
Okay.
The really cool thing about Rabbit here is when you go to define your on-demand plans, you literally pick which AZs you wanted to live in down here. A, B, C. That was it. I just told it, use these 3 zones for placing rabbit clusters. And think about what happens under the covers. Okay, it's going to deploy rabbit machine VM number 1 as part of a rabbit cluster, and Bosh knows what clusters are.
Right.
And it's going to say, okay, I need to put a machine into zone A. Well, I'm going to need an IP for that. And it goes into, the only subnet I can use is the subnet relevant for zone A, and the same for B and C. And
wow.
Yeah, up it came. So, well, there it is in the marketplace. So let me just open a prompt here. Okay. So let's go up to the next layer, the apps view. So the CF-CLI, or the apps manager, as we call it. So if we go in here, I have a set of services, and I want to look at this one first. This is RabbitMQ HA1. Now, I'm going through some Bosh DNS timeout stuff. It deploys and it works, but it takes half an hour. So we can kick one off, but we wouldn't be able to create one. Wait, so Martha stewarding the actual Rabbit cluster. And by the way, I shouldn't have called it a RabbitMQ node. That's the name of the app because it was written in Node. It's not a node of the Rabbit.
Yeah.
But
I mean, even taking, so like, I think this architecture that you showed, right? It's probably what most enterprises are trying to do manually still.
Yeah.
With all their data services, right?
Yep.
And to say that it takes 30 minutes to achieve an HA, a multi-data center HA Rabbit, message queue.
Probably just fine.
Everyone would be, that's great. Yeah.
Not a problem.
Yeah. Right. It'll take us 3 months to build this manually. Right?
Yeah. And so this is where it gets interesting. So this is the service key. All right, let's see, can we get into the dashboard first? So let's go here, and we'll blow this up in a minute once I get it. If I remember how to do this. Let's see. All right, so we go into the dashboard.
Well, it's looking promising.
Yeah. We have a password and a user. I think there's a user down here. Let's try this one. And the password is here. And let's see, can we get in? Woohoo! Okay.
All right.
So we have a Rabbit cluster running now. Just to prove that it's alive. Here's the interesting part. This hosts entry. So we talked at the very beginning about global balancing and how global balancers can sit in front of your local load balancers and how they can route traffic. And global balancers I like to think of as DNS with really short time to live. So they can blow up, and they solve a very clean solve a problem in a very clean way. So Bosh actually does the same thing. Bosh can create DNS entries that are capable of updating. And so if I just, because you need to be inside an app to resolve it, so I'll just CF SSH into Spring Music here.
Yeah. And yeah, that's another good point too. I didn't really ever think about this being an internal global load balancer within the platform itself, right?
Yep. And so let's take a look. We did a lookup of the host name in the service key for that cluster. And we can see that it resolves down to these three keys.
Can we zoom in there a little bit?
Yeah.
Sorry.
Yeah. So we're seeing a multi-pronged entry point when we want to connect to this cluster. If we go out to our app, so I have like I said, a little demo app here just to see it work. And we can just with test 3, submit and refresh, and test 4. And we're just pushing a few messages through. And to prove it's real, there we go.
There you go. Yeah.
They are actually going through the system. Now, if we go inside the machine, so if I just pop down into the Bosh layer. So I've been having fun, by the way. How many times have you SSH'd into your ops manager, some jump box, and then you set your Bosh environment variable so you can start using Bosh and looking around underneath the floorboards to see what's under the building? And I just wrote a few. After 10 years, I wrote a Bosh run alias, which sends my Bosh commands in to an SSH channel to the jump box. So I can just do Bosh run VMs, and the Bosh environment variables are on the other side. So I have my SSH key to my jump box, and boom, I can now look around.
Very cool.
And
we
this
lost.
is my rapid.
You might need to we just lost your screen, so you might need to reshare it in StreamYard.
No problem. Present.
And while we do that, shout out to Keith. I think he's really liking what's going on. You need more hardware. So very cool here.
Yeah. Did that screen come back?
Yes, we are back.
Thank you. So these are my service instances, and we can see the IPs that they're on.
Mm-hmm.
And we can see the DNS entry points here, and we can see the system works, and we share nothing, like not even sharing vCenter for the 3 nodes.
That's incredible.
Yeah, and so then again, a little tangent. I was doing bosh. So the service is called. If I'm out here on the outside, CF services, it's RMQ-HA1. Right, so I got carried away with scripting SSH commands. So I did a bosh SVC run, and I put the RMQ HA1 in there, and I can type something like instances, and it goes off and looks up the GUID of the service to get the name of the deployment, so I can just put commands in.
So I think you're also writing another CLI tool for us too at the same time.
So
I need to get more and see what's going on here. Like I think we could extrapolate off this use case here.
So let's stop this guy.
Like
this. So let's stop one of them.
Oh, so we're taking a node down. Yeah. What's going to happen? Problems?
Sure, this will be interesting. Your breath, everybody.
You should have just went and powered off a host. Took down one of your...
shut down pfSense, stop the routability to happen.
Yeah, I guess that would have been a little bit cleaner. Yeah.
Now, hopefully it only stopped one of them.
And not the entire cluster.
Not the entire cluster.
Like...
do not adjust your TV sets. I'm still waiting.
Executing stop on.
Yeah, post stop. We're past stopping. We're in. All right, now let's just see if that complained too much. All right, we got a stopped instance. What happens if we look it up here on this side? Oh, look at that.
Wow.
It's been pulled from the bosh list. Let's go back to our app and let's see if node behaves. I have no idea if this. Yay! Okay, look at that. Test 6. It's still delivering. This is a producer and a consumer.
Oh, okay, I see.
And it's just a really trivial app. But we still have an active cluster. Yeah. And we're still getting our messages. And we shut down a node, which could have been the failure of the Rabbit cluster node. It could have been the failure of the physical cluster. It could have been the failure of that entire VI infrastructure, that workload domain.
That data center lost power?
That whole data center lost power, and we still have an active messaging system behind the scenes. And undelivered messages had been acknowledged by at least 2 members. Mm-hmm. So if we only lose 1 member, we have cat theorem keeping us always consistent, which is huge. So I was getting really stoked about this because this may not be, it wouldn't be, the way we would deploy CF itself. We would have an apps foundation in data center 1, an apps foundation in data center 2, and then 3, or we'd just do the coloing, the witnessing in 3. Mm. However, if we want to do our services this way, we could define these zones and these CPIs in the same apps manager, or we could deploy a small footprint foundation and essentially externalize it. Mm-hmm. And we would be creating an engine for life cycling, not just one, but an entire messaging clustering system as a service, because we know all the great things we do for day 1, day 2. We know that if we have an update to Rabbit, we literally import a new tile, hit the button, and we will roll it canary style. We'll only take, remember, we're going to keep this rolling. If you wanted an auxiliary plan with Rabbit, you've got something I found recently about called the Warm Standby plugin, which is incredible, and it shadows all messages using Rabbit streams to an alternate cluster. Mm. So normally, a company will slice by data center as a fault domain. We're saying now let's make a horizontal that crosses them. Right. But you want a contingency to go to another horizontal should the first one fail. So if you really want to get sophisticated, you could do an async copy to an alternate instance of Rabbit also stretched across because we could just do CF create service. It'll go make another one. Here we go.
Right. Yeah.
We can just kick that off. Takes a while, but if I go into the apps manager, if we need another guy, it is literally go to our marketplace. Hey, I need another RabbitMQ that stretches the 2 data centers. Stretched one. Let's do it. RMQ HA2. And boom. And call me in 45 minutes. I think it's
nice.
But a Bosch job is off now, basically talking to 3 CPIs. In fact, one thing I do think we'll see in the next minute or so is that it'll start making the VMs sooner rather than later.
Yeah. Oh, yeah, for sure. You'll start to see those vCenter calls come in and start doing
in different vCenters.
Clone VM from the stem cell and things.
In fact, let's see the timestamp. Yeah, it's already started. Look, that's 1:37. Cool. And so it's making the VMs to constitute a new cluster already. And it's putting it into different vCenters live. And we saw the failover been super clean. We don't need to take these IPs and put them into F5 or similar if we don't want to. We could. But that was Rabbit. And then I thought, hang on a minute.
That's incredible. Wow.
Because the challenge you have today is that the contingency of a failure of an entire data center can be expensive. It's always operator involvement, and it's we're aspirationally always trying to get the shortest possible mean time to recovery. And for DR, there's all these conversations about how that works. For HA, though, we would really like the failure of an availability zone to be non-disruptive. So if you have a global load balancer, it could be a few heartbeats away from a triggered promotion of another, say, database. So that made me think, database. Oh, wait a minute. I've got this other tile called Postgres.
Right.
What would happen if I gave Postgres this stretched services network and this AZ zone 1, zone 2, zone 3 set of AZs? Remember, the Bosch layer back here, in theory, it's abstracting away everything underneath. By the way, when you create a Bosch zone using multi-CPI, it goes and it puts a stem cell in there. That it connects to that vCenter and parks a stem cell, so it's ready to multiply and make whatever you're going to make over there. What would happen? Well, I went into OpsMan. This happened like this morning, and I said, "Hey, let's balance jobs in ABC, and let's make an on-demand plan, and we'll call it stretched." And just like Rabbit, I said, "Go to zone A, zone B, zone C." And
very cool.
Now this is not the latest version. Latest version uses etcd. This one, it has a monitor instance in addition to the Postgres instances that get deployed. But if we go and take a look in Apps Manager again, let's go up a notch. We have our Postgres instance here, and our good friend Spring Music is deployed. Okay, it doesn't, I'm afraid, tell us about Taylor's music. Sorry.
No, it's okay. That one's been deprecated because that Spring AI code that was in that app is so old now that no one wants to update it, and we just moved on. We moved on to Corby's app.
Well, let's take a look. All right, we'll have to go old school, just regular Spring Music.
Just OG Spring Music.
OG Spring Music, and this Postgres connecting. Now, if I go in and take a look at that guy, so let's get out of this. We do CF services, and let's look at PGHA1. So let's take a look at a service key for this guy. So we go to our service, PGHA1, take a look, service key. All right, we've got an IP address hiding behind this guy. Let's take a look and see what that does for us. So let's CF SSH back into Spring Music so we can do the DNS resolution.
Oh, not again. CF getting directly into that app instance. Very cool.
Yeah. Now, what's very interesting here is we got an IP back, and that's the IP we're going to use to interact with the database. If we, again, let's use my other bash foo, and we do our bosh service run PGHA1 instances. We have 20103 is absolutely one of them. It's the Zone A instance of Postgres.
Okay.
But we've got a Zone B and a Zone C. All right. We can see that Spring Music is working just fine. We had it running over here. And if we change a reference, so let's do Abbey Road. We'll change Abbey Road to Abbey Road 2. So I made a database update. Now I've got pgadmin over here. And I've connected to a couple of the members. And let's go into 2103. And I think I might have to reconnect. And we go down to the database and come on, databases. Yeah, where are you?
Anyway, let's zoom in there. I'm not sure if you can do it on PG yet. There we go.
And so if we just look at the columns, show data. And we should see our Abbey Road in here somewhere. Abbey Road 2. Okay, so we have a record in the database that's behind the IP address that we just saw Spring Music using because the service key revealed that. But if we go to this other one, this 10.1.101, which is, what is that? That is Zone C. And we have a look. And we go down into 10.1.101 and we view the data from there. Really hoping that this is a non-event. We just see everything the same. There we go, Abbey Road 2. Now, what happens when a database fails? Because it's so let's
chaos, panic, everything breaks.
Yeah, right. So,
run around with your hands up in the air. I don't know. Just run away.
PGHA1 stop. The 10 what is it? 103 is the active guy.
Mm-hmm.
And if we stop that guy, now I can't remember the Postgres command, but you can actually in here ask on the maintenance or the table. You can ask it, "Am I the active?" Am I leader?
Yeah.
Leader. Mm-hmm. And you can find out. And so behind the scenes, Petroni is going to do the I think it's Petroni, or PGHA plugin. I can't remember which one. Depends on the version you're using from us. But it's going to do that promoting of one of the followers to be the new leader, either manually or either automatically or manually. In our case, we should see it done automatically. So if we see our instances now, we should see we've stopped one of them.
Right.
Now, if Spring Music tried to use this IP address, it would not get there. What's interesting now is we're getting back. Hang on a second. Did we get the Postgres one? Yes. We got back one of them. We got all of them. Interesting. I thought I was only going to get one of them back. Let's see what happens when we go to use Spring Music.
Well, this is what testing live is like.
Yeah. Well, we are connected, and we have.
Where'd Abbey Road go? Is it the sort by filter there?
Yeah. Where are we? Which one were we on? We were on Abbey Road 2. So let's change it. Oh yeah, there it's down there.
It's right there. Yeah. Okay.
Yeah, okay. So let's just change it back to Abbey Road.
I mean, it's clearly still have a database connection. Otherwise, it would have puked already.
Yeah. So we changed it,
and
now we're in this other mode. And if we refresh here, okay. Abbey Road.
All right.
We've made a commit to a database that was not the leader database through a Spring Music app that never ever out in front of us. It made the reconnection because the connection was dropped. The Bosh DNS, I guess, behind the scenes of NSLookup gave it a node that was actually active. And hey presto, we are alive with a HA database across data centers. So picture the scenario where you're globally balancing. I say global, but what I really mean is metropolitan area network. Cross data center balance traffic comes in. You could either go active, depending on the backing service. Like we haven't even gotten to things like Gemfire, where we could have a memory grid latency synchronization. But if you can have a database as a service, and I can't remember how many seconds the SLA was before the secondary instance was made into primary, but your rabbit was always active. And so you could have patterns for app teams that if you can't commit to the database and you really need to move on, maybe drop it into a durable queue and it get picked up. If your database, and then when your database, can have a task that would pop messages off queue and watch for the database and commit them if needed, when possible. But your database should come back in the alternate site in just a matter of seconds, as we saw here. And so you put all these pieces together, and I think we get this story where if you're building, in quotes, modern applications, enterprise applications, and you care about availability, the real magic happens when you can stretch the backing services between your fault domains for HA, and then for secondary level for fault tolerance asynchronously.
Yeah. So, I mean, I think that's a really good point. So this is probably like the still dream state, I think, for a lot of, I would say, enterprises running like, on premises, right? This is still very, I mean, I have yet, like, I mean, honestly, I haven't really seen anything like other besides Bosch that can do this type of thing.
I don't want to think of the playbooks you'd have to write or the public.
Oh yeah, I mean, you're either just doing a bunch of manual VM deployment installs, a bunch of just networking rules and everything to try to get everything mapped together and wiring that all up. I think that, I mean, if anyone's watching and has a better anecdote, I think that's still how like most enterprise databases at scale work. Yeah. If you're not kind of consuming this type of model where it's a lot of like manual work, a lot of, that type of thing. Now, maybe there are some services like in public clouds that kind of get similar. Obviously Bosch was based off Borg, which was like, the genesis of Google Cloud Platform.
Right.
So I think we just, this is a technology that I think a lot of people just don't even realize they have. Right.
100%. And think about this for a second. We've always only talked about Bosch/CF services to support CF apps.
Mm-hmm. Mm-hmm.
But if you talk to people like Kafka people, they talk about Kafka apps, not apps that use Kafka. Rabbit apps are very much the same, and Rabbit Streams apps are frankly just as performant. And that by the way, quorum queues and streaming in Rabbit, which is order of magnitude more performant, both work in this architecture. I've checked it out. Mm-hmm. But this does not have to be exclusively in servitude of PCF apps. These can be data services, messaging services, caching services that are open for business for anyone to consume. And worst case scenario, using no new features, using what's out of the box, I have service keys I can get in a single command, plural, right? Mm-hmm. And at worst, I would take the IP range that's been given, the IP list that's been given, and balance it manually. If it's routable from the load balancer back, it's exposed. So really, really powerful construct here. And like you said, that automation in a self-service provisioning abstraction behind the scenes, like think about it, you could have 50 or 100 of these deployed. Right. And I've always said CF create service is, in my opinion, more powerful than CF push. With 50, 100, several hundred of these deployed, a new critical fix comes along. You can roll OS patches through OS embedded in a single command, or if they want to schedule it, you can stage it with the Bosch update and then have them do an update instance explicitly. So you don't have to force everyone into an upgrade scenario at the same time, even if it's rolling, even if it'll do it without going fully offline. They've got that choice to operate how they do. Because I've seen this in enterprise. We can say it won't go down during an upgrade. They still want to do it on Friday night. That's fine. Yeah. They may say, hey, I've got 2 clusters here, this one and the second one underneath it that does the same thing, but it's just a backup. Mm-hmm. Let's only upgrade the first one. Sure, we will always have the second one. And it would take catastrophic failure. Because remember, Bosch stops if a zone upgrade doesn't succeed. Now, we're used to seeing that in a cluster in a rack. Right. But it means if data center 1 has any problem starting all new jobs and getting a full healthy running state out of them, it won't touch AZ2 or AZ3.
And that service, you may be in a halted upgrade state, but your actual service is still up and running.
Right? No business impact. And that's the message. Can we do these services that can give applications true zero business impact outcomes for entire data center level failures? And I've heard from colleagues that in Europe, there's a lot more of the metropolitan area view. It's not as common in the US. Mm-hmm. When you use AZs from, say, Amazon, they are different buildings with like terabit interconnections, but they're different buildings. here's my point. You don't need to go to a public cloud. You can do this in a sufficiently high quality interconnected set of sites today. And I know that some of the biggest revenue generators for the hyperscalers are their managed data services. It's one heck of an uplift from EC2 to go to, stretched RDS.
Right. Oh yeah.
Massive. And this is running open source, latest and greatest messaging and data services. So yeah, I just I love my favorite piece of all of this is that the people up at this level have an agreement from operations as to what the SLA is in the plan, and they just hit the button.
Oh yeah, not only are you getting that ease of deployment, a matter of minutes per se, self-service, right? That platform engineer controls the plan. So backup policies, different, organizational policies are all already managed in there. On top of, the multi-zonal deployment or regional deployment of a data service. I think this is this is really kind of rethinking how you could potentially architect these deployments of before, like back in the day, we had the global load balancer, across two data centers, which Metro links, right?
Yep.
But we didn't really get too much into the data, right? And our data was still very painful. It was very much like, all right, we're manually, deploying nodes or VMs off platform. And in most cases, the data vendors would come in and say, all right, we could run on like Helm charts, Kubernetes, everything. Then they saw the scale at which our data was, and they're like, how about we don't do any of that, and let's just we want bare metal servers. And we're like, whoa, like that conversation happened. So I think this is a really good, interesting benefit as well, is that you're also getting direct VM level performance and availability of these services that can be quite chatty and quite performance hungry. So you have that benefit as well.
Yep.
And just CF create service, boom, right across three separate data centers without, with only the real metric of you need routing between them two, routing between the three, which is
exactly. And so I'm thinking about, like you said, how long is someone going to spend imprinting the process to even the runtime to get a stretched rabbit cluster set up explicitly? Now do it 100 times and maintain them on day 2. And what's our upgrade strategy? What's the SLA on backup? How do we make sure there's no config drift?
Well, even if you get one, just to say one node going down and having that getting the cluster to actually fail over properly or survive that node outage properly is even still a challenge, because what are you going to integrate to, like an external DNS provider? How's that DNS actually working? Like, what's the bosh? The fact that bosh can just auto do that and on the fly, I think is a very
I've
got a lot of new projects that you just started off in Kuhn Labs home lab data center services. Now I need to try.
So I haven't done this yet. Let's see, bosh service run RQ on start that job. So I was chatting with the Rabbit team about what it means to recover, because failover is one thing, failback is another.
Right.
And I've been told that if you restart, when it restarts, it's a near instantaneous resync. That the Rabbit brokers within a cluster are super efficient about how they will essentially get back in sync with each other. Which is a horrendously challenging problem normally. But you restart a lost node, it'll come back, and the system will come back to its full setup. And remember, the DNS entries will also automatically get fixed, because bosh will put that back. Now, in the worst case scenario, it might even have to create a new one. Maybe the machine blew up. This is the partnership between the bosh layer and the implementation of the clustering technology for that data service really are perfectly complementing each other. So let's see if he's on his way back up. He's still stopped, but I'm sure he'll come up in a minute. But yeah, it's fun stuff. I think we got some interesting stuff here.
Yeah. Oh, and then even too. So, I mean, I guess if I was trying to, coming into I'm refreshing my gear, I'm refreshing my foundations, I'm rethinking my architecture. I would definitely go this route, and I really like the thought of we've even introduced the like AZ aware Go router too as well. So if we have other large customers that have been running this in this regional deployment type of treating each AZ as its own data center with the metro links, but they came to us and said, hey, we want the Go routers across all 3 zones to route to the local Diego pools to really just get that avoid as little shrink the intercall service latency as much as possible, right? And if you're at scale, what every call, every SSL termination is milliseconds, and you want that call stack to be short as possible for performance, right? Any optimization is great there.
You made me think of another one. When we used to run different foundations for internet facing versus internal traffic, then isolation segments came along. Put your isolation segment in another workload domain, its own vCenter, its own network configuration, its own SDN rules. The multi-CPI thing can be very interesting on the app side as well, to your point. But in fact, what you described is actually what I've been going through this year is refreshing what we would consider to be best practices and kind of what's out of the possible in 2025 that we weren't thinking that way in 2015. And it's next level stuff here. Like these availability metrics you're going to see are spot on. Let's see. Yeah, look, we're back. I just restored the cluster to full health.
Very cool.
And off we go. Let me think. It's RMQ HA. My service key would see it. So pretty cool stuff.
Very cool. I mean, even too, like you can still have your global load balancer. You have your 2 foundations. You can stretch them. Oops, hitting my mic. Sorry about that. Stretch them across the three data centers. But that again, the problem would be the data tier. But if you have your active, and do like the cold, the replication on the failover side. So you could pretty much have all your bases covered. Have the benefit of that, but then still have that DR type of functionality just ready to roll if needed.
And remember, if you are running a system where you want an even next level, if you have a global balancer, you can take an IP out of the pool. So if you got really if you wanted to kind of go beyond what's in Bosh itself, I could take these IPs myself and use them because I'm an external foundation and I've created the ingress for these IPs to be available. Yeah, I can go through the HA proxy, but if I want to have more control over it, I might at an F5 level say, hey, I want to take traffic out of data center 1. I'm going to stop reporting back this IP when it's live. I'm going to stop traffic going to that one. And I'm going to funnel the traffic to these 2 only ahead of Bosh health checks taking it out of commission. And now I can do the same thing at the app layer. And, you can kind of see that build up into ways that you can take away pretty much all risk from any change to the system because you're kind of putting one under maintenance if you want to.
Oh, yeah.
And there's different ways to think about how this tech could be leveraged or this yet another hidden Bosh superpower.
Yes. Yeah. And as on the green room conversation, we were if you've seen some other Fynes' other shows, he likes to show the hidden superpowers that we may sometimes forget about. So this is really just starting out the new hidden superpowers of Cloud Foundry and Tanzu platform with Fynes.
So there we go.
Very cool. Well, I mean, this is I'm excited. I want to build 3 separate V centers now and data centers, and I got multiple ISPs. I can make it. I can put something out in the woods and have it be a data center, and you
can reach enough hardware to do that without even getting off your chair.
Yeah, I'm gonna start burying some fiber across my property and create new sites, and we'll get we'll expand to the Coons web services to even more regions.
Love it.
If anyone's looking to host to be an expansion partner in the local Cincinnati area, let me know. We'll figure out some deal. But cool.
There you go.
All right. Well, I really appreciate you coming on the show. One more comment from Keith. Everyone's definition of AZ is different: rack, room, hall, building, city, country, etc. But yes, and hairpinning, everything. So these are all. I hopefully we've demonstrated how we can maybe even take it at the most highest global level and kind of go from there. But yeah.
Yeah, and I think that's a very fair point, because I found it challenging terminology overload. Exactly to Keith's point, we were thinking an AZ is a rack historically in the data center, but a lot of companies think of a zone level or a data center failure as a zone failure if they have two data centers in close proximity. Now, is a Bosch or a CF zone rack 1 in data center 1, or is it data center 1? And we've, it's important that as we rethink best practices, that we make sure we clarify these terms. And zone failure, maybe we've got multi-layer zone failure, right? With the zones within the zones, but we need some new terms.
Yeah. Well, I think that's a good point, and I think too it's I have one more thought on this, and then we probably should wrap the show up for a bit. But I was actually with another kind of like newer customer earlier this week, and they were talking about the multi-zone approach and multiple racks, and like how many hosts do I need to do the 3 zones. But even with small runtime now, you can get a very short footprint, and maybe kind of even reduce that overall footprint. So you could even maybe do something very similar, but with maybe 3 small runtimes or something of that nature too. So
yeah. Oh yeah, that was last point. What if you lose Bosch? What if you lose AppsMan? What if you lose that entry point, your control plane for these? Well, remember that I said let's have a second one. Well, there's nothing stopping us putting another small footprint foundation in Zone C. Make that its home. So we create one out of Zone A, and we run it, and it stretches, and we lose Zone A where, it doesn't matter, everything keeps no business impact. Operationally, we're not able to make new ones, but we could have an alternate way to make new ones that's based out of Zone C. So we can play with, restoring Bosch to another site, but if we wanted to have an alternate path, the small footprint foundation and a Bosch manager is not a huge overhead. It's a rounding error in the grand scheme of things. You can kind of have auxiliary locations from which you can create another set of services. Whether you do it that way, or whether you kind of do backups and restores, or you send your Bosch layer over. These are all choices that you can make. The thing is, the architecture supports whichever way you want to go with that.
Very cool. So I guess key takeaway is, if you're interested for regional data services, you should definitely check out Tanzu platform and what Mark's been working on, and the rest of the team. Thank you all for watching. This is the time. I guess we should don't forget to like and subscribe. I guess it's pillow talk time on the CF Weekly show, because every time I bring out this terribly huge pillow, I did not bring it to Palo Alto, thank God, but it was missed. Nikki brought it up and said, "Where's your like and subscribe pillow for this portion of the segment?" But with that said, thank you so much for coming on the show, Fynesy. Any kind of closing thoughts or next steps for the audience, so to speak?
I'm just tire kicking this, trying to clean it up. We saw Bosch a little slow making those clusters. Halfway through that one, we kicked off while we were making it. So watch this space. We'll try and get a blog out on it. And I love feedback on what we're doing, and how to meet the needs for the next 10 years. Frankly, a lot of the stuff we've already built, we're just learning how to use it better. Yeah, well said. All right. Well, with that, we'll wrap up the show. Thanks for everyone watching, and then we'll close out with a CF bye. 3, 2, 1. CF bye.